So hello everyone and welcome to the CLARA project webinar series. So today it's the fifth episode or fifth webinar of the series. The topic is on atmospheric dispersion modeling and evaluation of meteorological variables on air quality. So we'll be presenting two services which will be discussed a little bit further on. But to start, let's just spend a few words on CMCC, who is enabled who is hosting this webinar series. So the mission of CMCC is to investigate and model our climate system and its interactions with society to provide reliable, rigorous, and timely scientific results, which will in turn stimulate sustainable growth, protect the environment, and develop science-driven adaptation and mitigation policies in a changing climate. So CMCC is a network that is located in 7 different locations around Italy. So we have in Venice, in Bologna, Milano, Viterbo, Capo, Lecce, and Sassari. Each one of those comes with different research divisions. So for instance, in Venice, we have the ECIP division and the economic analysis of climate change impacts and policy, and also the RAS division on risk assessment and adaptation strategies. So in total, we have 9 divisions spread out throughout this network that presented on the last slide. So the CMCC topics, so the topics of research that we touch here in CMCC varies a lot. So from modeling to policy adaptation to also oceanic modeling, ecosystem computing, and also services. So services is of particular interest to this webinar series. So because we're going to be talking specific about some climate services that have been developed inside the CLARA project. So if you want to follow like the activities that CMCC does, you can find us, of course, in the scientific publications. You can also follow us in events and education events as well, and also in communication. Talk a little bit also about communication. You can find this webinar of today. So it's going to be recorded, and you can see that on YouTube and also on the website of the CLARA project, and also on the Facebook of CLARA. And if you have any further question, please, you can send an email to the email that you're seeing right here. So just a few words on the next forthcoming webinar, that it's going to be about the C3S demo case soil erosion on handling soil loss hazard through Copernicus data and tools. So this is going to be on the 5th of December, so pretty soon. So I pass the floor now to Nico, so he can present the services of today within the CLARA project, and thank you.
Thank you, Arthur. Welcome to everybody. My name is Nico Bonora. I'm from ISPRA, the National Institute for Environmental Protection and Research. We are deeply involved as well as the CMCC in the implementation of a national activity, also, as well as the European one of the Copernicus program. Then it is really fit on both our task and our role on dealing with environmental issues and climate. So I will start now with presenting Roberta, Roberta Amorati, that is giving the first presentation. It relates to the Aqcli service that provides a tool to produce statistical analysis on how future climate could impact on accumulation of pollutants. It is aimed at the evaluation of the contribution of meteorological conditions in future scenarios, considering no variation in emission. So I kindly ask Roberta to present herself and to start with the presentation with a few seconds that I'll give you the presenter rights. Okay, you're enabled.
Okay, thank you, Nico. Good morning to everyone. Okay, my name is Roberta Amorati. I work at ARPAE, the Regional Environment Agency of Emilia-Romagna. I work with the numerical prediction for air quality unit at the Hydrometeorological Climate Service. The presentation I'm going to make is the outcome of the work by the all group members and other colleagues in ARPAE. The service we have developed within the CLARA project is the Aqcli service. Its name is an acronym and stands for Air Quality in Future Climate. The motivation for this service arises from the increasing awareness of the impact of air quality on human health. The demand for knowledge by people is growing, so that the demand of knowledge by local authorities is increasing as well. The questions, will different climate conditions in the future impact on air quality? In which way and how much? What will be such impact on a global scale and above all on a local scale in our country? These questions are open questions, and the evaluation of the impact of climate change on air quality is still under investigation. So the Aqcli service addresses this issue, and it is meant to investigate the air quality in present climate conditions and compared to future climate scenarios. The target area of the Aqcli service is related to the activity of our agency. We are a regional agency, therefore our products concern mainly Emilia-Romagna. The focus of the Aqcli service is an area centered over Bologna that is 150 times 150 kilometers wide. For that area, we have know-how and experience. ARPAE manages the air quality station network, and we have all the ancillary informations. Furthermore, for this area, a complete data set of meteorological variables for present and future climate was already available within the project. The considered area includes the city agglomeration, a flat area in the north, and a mountain region in the south. In this area, there are some populated towns, are Modena, Ferrara, Reggio Emilia, Parma, and they are representative of urban conditions. The Po Valley is one of the most polluted areas in Europe. Many pollutants may have effect on human health and are all monitored. For the Aqcli service, we concentrate on particulate matter and ozone. The former is one of the pollutants responsible for low air quality during winter, and the latter is one of the responsible of low air quality in summertime. These two pollutants, among the others, are measured and taken under control. European laws and Italian laws have established some thresholds that cannot, or at least should not, be exceeded. The PM10 daily concentration should not exceed the threshold of 50 micrograms per cubic meter. In order to be compliant, no more than 35 days per year of exceedance may occur. The ozone concentration is regulated considering as a metric the daily maximum of the running mean over 8 hours. This value should not exceed 120 micrograms per cubic meter. The target is having no more than 25 exceedances per year, considering an average over 3 years. The long-term goal is having no exceedances at all. So now the question is, will be the future climate favorable for us to be compliant and reach these goals? We know that the concentration of pollutants depends on three main components: emissions of primary pollutants and precursors, chemistry, so the chemical transformation of precursors, and meteorology. Given that we can suppose chemistry will not change, the Aqcli service considers no emission variations and estimates the contribution of meteorological conditions. Meteorology acts either on reactions, but also on dispersion and accumulation of pollutants. To accomplish this task, the Aqcli service applies a statistical relation among meteorological variables and days with high concentration of pollutants. Some significant meteorological variables are considered. During summer season, the ozone production is intensified by solar radiation. A suitable proxy variable for radiation is temperature. In fact, there is a strict correlation between temperature and ozone concentration. For the area around Bologna, a threshold has been found to fit this relation. So when the daily maximum temperature is higher than that threshold, we can say that that day is favorable to ozone production and accumulation. For PM10, the relation between meteorological conditions and high concentration has to consider more variables. PM10 is partly due to primary emissions and partly is secondary. So in this case, Aqcli considers the relation between meteorological and dispersion or accumulation. High concentration of PM10 occurs when the boundary layer is small, when the wind speed is low and there is no precipitation. In those cases, the day is considered to be favorable to PM10 accumulation. The thresholds for these relations are tuned for the area around Bologna and are typical of present climate condition. The Aqcli service relies on a dataset of hourly meteorological variables simulated for 5 years in a present climate scenario and 5 years in a future climate scenario. The considered years were selected by defining typical meteorological years. We have a neutral year, one in the present and one in the future scenario. We have a cold, wet year in the present and one in the future. A warm, dry year in present and one in the future. A cold, dry and a warm, wet typical years. So we can think of this dataset not only as a time series or a sequence in time, but rather a description of weather types in present climate and in future climate scenarios. Starting from the input dataset, the required meteorological variables were extracted and a map of number of days favorable to pollutant accumulation is created on a grid with a resolution 1 kilometer. One map for each year is created. The sequence of maps is shown in this slide for ozone. The maps show that ozone is more favorite in the flat area, where the red area is wide, while in the mountains, ozone accumulation is less probable due to lower temperature. It is clear that in future scenarios, the number of days per year favorable to ozone is higher, generally speaking. The same gridded data are produced for PM10. For this pollutant, a trend in future scenario is not clearly identified because of complex relations among many variables that contribute to dispersion. The maps give an overview on the whole area, but the Aqcli service focuses on single territories, especially for urban areas. The values inside the municipalities is therefore extracted and analyzed in detail. Bologna extends in about 100 square kilometers. and the distribution of values in the area may vary inside it. We can represent it by means of an histogram or a box plot. In these pictures are shown the time series of box plots for all the years of present and future scenarios, starting from 187 to 2063. From these charts, it is clear a trend for ozone, while for PM10 the relation appears to be complex. In order to evaluate the variation of the number of possible exceedances, an analysis has been conducted during the development of Aqcli service. As a representative values for each distribution, for each year distribution, is taken the median value. So for every year at a given location, for example, Bologna, we consider one value. We compare coupled years, the ones having the same meteorological type, the true neutral, the true cold wet, the true cold dry, and so on. Ozone and PM10 are analyzed separately. The first step was determining if the two distributions were significantly different. It was done by applying the Wilcoxon test. Then the data was computed between the median values. So once the distributions are known to be different, the delta in percentage is computed. In these tables, there is summaries of the results for Bologna and Modena. The first table shows the results for ozone. The percentage increment is positive for all the weather type and for both cities. The range is between 26 to 46% for Bologna and between 26 to 56 for Modena. In the case of PM10, the increment is negative for three types of year: cold wet, cold dry, and warm wet. It ranges from between -4 to -22. For warm, dry, and neutral, the percentage increment is slightly positive, between 2 and 10. And there is a couple of years, the neutral, for which the distribution is not significantly different, in the Modena case. This analysis can be carried out for all the territories, especially for wide territories, where it gives more significant statistical results. Okay. The outcome of Aqcli service may be visualized by means of a web tool, which has been implemented during the project. It is an open site with no login interface, and it is freely accessible at the link here. The tool can display maps and basic statistical analysis for every single municipality. The initial screen shows the target area in the Emilia-Romagna region. The area around Bologna where the service is available is highlighted. The geographical domain can be zoomed in and out and navigated. On the left side, there are some menu bars from which it is possible to select the parameters we are interested in. The top bar permits to select one of the two pollutants, either PM10 or ozone. By means of the second menu bar, it is possible to select the period we are interested in. It is possible to visualize the okay, so the first show is the map for the year selected, the pollutant, and the whole area. In this example, there is the map related to the year 2006. It is a PM10 map of days favorable to PM10 accumulation. Here is a map of PM10 related to 2050 with another color palette. And here is the map of possible exceedance for ozone in 2010. From this show, it is possible to explore the statistical analysis concerning single territories. By means of the third menu bar, it is possible to select the municipality we want to look at. The selection can also be done by passing through the mouse on the map. And once we have selected the pollutant, a year, and the territories, it is shown the distribution of possible days favorable to exceedance as an histogram. And then selecting the whole period, it is possible to see the sequence of box plots. Here it is shown the time series of possible days of accumulations of ozone in Bologna. And there are also some graphical tools. By passing through the single box plot, we can read the number. There are also some visualization options by the widgets in the page, and the images that are displayed on the screen can be downloaded as PNG files. Okay. All the data produced for the Aqcli service are available to any interested user. They are available at the ARPAE open data site that can be reached at this URL. It is a CCAN portal platform. The main page is very simple. We see that there are some data sets, the all data sets available at ARPAE. By clicking here, a complete list appears, and among the other, the ones related to CLARA Aqcli is this one. When clicking on the dataset link, we get the page. There is a description, a short description of the service, some metadata information. The dataset is composed by 5 resources. The first is composed by the grid data of days favorable to accumulation on a 1 kilometer resolution grid. It is in net CDF format so that the user can download the files and do the statistical analysis by himself and improve the analysis by calculating the parameters he requires. The second resource is composed by the images in PNG format. The other 3 resources concern the statistical analysis for each municipality. The files contain the summary of the distributions for every municipality. They are available in text format as common separated values, and also in vector file of polygons in shapefile and GeoJSON format. And this is the end of my presentation. I think I have talked enough. So thank you for your attention. Thank you for being here.
Well, many thanks, Roberta. Very clear, and it seems the system will be very helpful in for also different user communities, and then in order to make it available for other user. I would like to have a couple of questions, unless I have some question from participants. Let me. So I will start asking you if this service has the capacity to be extended to other areas.
Okay, this service relies on a statistical relation that has been tuned for the area around Bologna. We think that this relation may be valid also for the Po Valley or the area near with the same meteorological and emission characteristics. So I would say yes, if a data set of meteorological variables in present and future is available. Maybe for far location, the statistical relation should be tuned, but in principle, it is extensible.
Okay, thank you. But do you think also there is some sustainability beyond the CLARA project for your tool?
Well, the open data still remain are still available. So the users can download the data set also after the end of CLARA project. The visualizer as well will be online, but maybe no maintenance, no development on the visualizer will be done.
Okay, thank you very much. Let me see if I have some more questions from participants. No, it seems there is no question. I will wait 5 seconds to see if maybe someone have to make. Okay, no question from for you. Any more questions? And thanks a lot for the very clear presentation. And I will shift the presenter right to Christian. Okay, so Christian Asker is from the Swedish Meteorological Institute, and the AirCloud service he will present is a cloud-based air quality modeling tool for high-resolution assessment of air quality using Copernicus climate change service, and as well as data and input and boundary condition. The service provides a tool to efficiently calculate concentration of pollutant either inside street canyon and for a specific area. So, Christian, the floor is yours. Please start with the presentation. Thanks. Sorry, did you see what I said? You can speak.
Okay, thank you for unmuting me. Okay, thank you for the nice introduction. I will now talk a bit about the SMHI AirCloud service. And I would also like to thank Roberta for her presentation, because it also gave a nice introduction to air quality issues. The purpose of the AirCloud service is to make it easier for persons working in air quality to do air quality modeling. So in Europe, it's the legislation that, as Roberta showed, that says that each city municipality is responsible for maintaining the air quality at a reasonable level. And so the aim for us is to use upstream services for climate and meteorology and background air pollution to provide a simple tool that can be accessed through a web interface to do modeling of air quality, called dispersion modeling usually. So I will try to show the AirCloud tool as it is now. It's still in some development, so there are a few corners to polish and so on. And there's first the start page that shows the content of the service, and the user case that we have done in the CLARA project is the Rotterdam area in the Netherlands. So if you click get started, usually you get a list of your different air quality management projects, and we can create a new one. I will try to do it not too fast. So we can zoom in on Rotterdam area on the map, and then we can see the area we would like to model. Give it a nice name. And what happens when I press create is that it will copy the input data that we have already stored into the system, which is all the necessary information to do the air quality management work. Now, of course, it could be the case that one has to change some input data. Now, when we have the main view, which is mainly composed of a map, I will show you the main component. Sorry, I'll just try to get this out of the way somewhere. So, sorry. We have some main panels. On the left-hand side, we have what we call different modes. We have a pollution mode, which means modeling, and we have an edit mode, means edit the input data that is used. We also, on the top bar, it shows the project that we're working on, and it also shows a drop-down menu of scenarios, which I will talk to you a little about in the end. Typically, when you get this type of input information, we have all the roads available. We have point sources also, and these are data that comes from the regional authorities in the Rotterdam area. So what we now can do is we can select a small junction to model, and we have two types of models. One is we call roadside, which is the pollutants in a street canyon, just at the side of the road, as the name implies. And we also have what is called as a rooftop, which is an averaging model that will show the pollutants equivalent to what will be measured at the rooftop level. So if you click on a road like this, we get some name of the road, and then we can press run simulation, and this will use what we call the roadside model, which is a street canyon model. And that will give you slightly different results on the different sides of the road. So now it has completed, and we can look at the data. And I should also point out that these are preliminary data for nitrogen oxides. They still need to be some validation, of course. And if we want to, we can select more than one road, and it will calculate all of them after each other. Of course, it's not only interesting to see the air pollution level inside each street, it's also interesting to see what happens a bit away from the roads. So we go to what we call the rooftop mode, and here we get a new panel on the right. We have two main options. One is called Junction, and one is called Urban. And I will only show Junction today because Urban will take much longer time. We can also select a resolution for our modeling grid, and then we can click on an area and we select the area we want to model. And now we will also see all of the sources that will be included in our calculation. And if we would like to include sources even further away, we can change what we call the emission buffer, and you can see that the amount of sources will increase. Now, if we're happy with this, we can just press run simulation, and hopefully we don't have to wait so long. I will just check if I got the message. So now it takes a little while because when you press calculate, what happens is that we run through the whole period we have selected, which is 1 year, 2014 now, and we do a simulation for each individual hour for this period. So that means 8,760 hours are calculated, and for each of them, the meteorological data and the emission data are calculated and used as input for the dispersion model. And once this is complete, we will also add the urban background from the surrounding city. And now it has completed, and then we can go and have a look at the results. And by default, we show the background information data set, where we can switch to our calculation. And you typically get a bunch of different variables depending on what statistical measures you would like to see. If we just look at the mean value for the whole period, including the background, this is what we get. And we can change the opacity. Now, of course, we can also click on different parts of the map to see what the different pollutants are here. We can also choose to export a time series for that point into a comma-separated value format. So you can export it and do some analysis, compare it with monitoring data and so on. So this is the main idea. So we can easily select an area, do dispersion modeling for 1 year. Now, of course, what is also interesting is to be able to change the input data. So if we look at the edit mode, if we click on roads, it will be colored after how much traffic we have on the roads. So we can, for instance, click on one road, and then we will get some information about the road, and you can change the properties, how much traffic you have, speed limit, how much heavy vehicles, the congestion profiles, and so on. And now, once the user sets up a product, it's all default data that is based on the data we have received from the municipality of Rotterdam. And of course, this is good on the average, but in some cases, the user will have detailed information about the certain road and so on, and then it can improve the quality of the simulation by changing these values. We also have point sources, which can be edited, and you can change the properties of the chimneys, and it's also possible to change, of course, the emissions and add for more substances and so on. There is also one edit mode, which is called buildings. And this is the building data set that we also store. And this is used when we calculate what I showed you before, they call it roadside mode. Then the height of the buildings on each side of the road is important for how the pollutants are trapped inside the street. So when we set up a calculation for a road, the model will look for the buildings that are surrounding the road and then calculate the street canyon from this. So if we want, we can then change the buildings or the height and so on. Okay, so far. I would also like to briefly mention the other mode for rooftop simulation. And as I said before, we have what we call the junction simulation, and that is only for a junction, meaning a few roads on a smaller area. Now, if we would try to make a large area here, it will show in red. And the reason for this is that since we also include the background of pollutants from the rest of the city, if we have a very large local modeling area, we will include some emissions twice. And that, of course, will lead to the wrong result. But in the method that we call urban, it will we can only select modeling grid that is connected to the background data for the urban background of pollutants. And then we can select it such as this. And once we have done that, we can zoom out and see that we will include all emission sources in all of the neighboring areas as well. But we will only calculate the concentration for the local area. And then the model will pick the upstream, regional, and urban background in a way so that double counting of emission sources is completely avoided. Now I can't show you this simulation now during the webinar because as you see, the amount of sources is quite large and it will take a quite long time to show, I'm afraid. Yes. What else can I show you? I can also show you what I briefly mentioned before. The drop-down menu here, that is the scenarios. And if we go to manage scenarios, we will get a list. So far, when we set up a project, we will always get a default scenario. And as I talked about before, when we set up the project, we will copy all the background information, the emission sources, the buildings, and so on, will be copied to a local copy that we can change without changing the original data. And it's the same with scenarios now. So we can make a new scenario either by copying default or copying if we have more than one scenario. So we will just call it something nice. We could call it scenario 1, for instance, and add a description. Now, so far for this demonstration, we have only loaded 1 year of data, but of course here we could select more than 1 year. And the background information for this service is the Urban Cities project. And that has data for the current climate and also for future climate. So that can be used. Though I would like to point out that in air quality, even though there's an effect of the climate change, the main uncertainty is still in the emissions, which we don't know so much about for the future. Now, when we're happy, we just press create, and then we can go and we can pick our new scenario. And in this new scenario, we can then make changes. For instance, if we're not interested in modeling another period and comparing them, we could make other scenarios such as what would happen if we would build a bypass around the city for the main heavy traffic, or if we would impose laws regulating what type of vehicles can travel on certain types of roads, and these type of things. So this is the main purpose of handling these scenarios as well. Yes, and of course both the roadside and the rooftop models may be used in both scenarios. Okay, I think I will stop there and see if there are questions.
Okay, let me check if there are questions. So first of all, thank Christian for the very clear presentation, and also for the online presentation that is always challenging, and it seems it show a very robust system. And I have the same question to you as the one made to Roberta, the CLARA, if the coverage of the area can be extended, and also the perspective after the CLARA project.
Okay, thank you very much, Nico. Yes, of course, when we started this project, we already had the idea that it would be very nice, of course, to do a service that could be extended to at least any city in Europe. Since we based the background data on the project, At the time, we had hopes that Urban Cities project would be extended to more cities in Europe, which didn't materialize. But in principle, any type of climate or meteorological data set can be used. So we need meteorological variables for the modeling. We also need background concentrations of pollutants. And for instance, we could use the CAMS data, and we can use other online sources for the meteorology. So it's definitely possible. Now, of course, the main issue in air quality is always getting good quality emission data. So that, of course, varies from different cities, what is available as open data and what is not open data and so on. So, but in principle, it's definitely possible to extend it. And we have had questions already to extend it to areas in Southern Europe. What will happen after the CLARA project is that it's a little funny in a sense, because when we started the CLARA project, we already have a system in Sweden called SMHI, which is slightly similar, but it's very tailor-made for Swedish conditions, and it's mainly for traffic. So idea was to make a European version of this to make it easy to model air quality somewhere in Europe. And now it's probably the case that we will base the new SMHI based on this AirCloud tool instead. So we will most likely have Swedish municipalities will use not perhaps an identical tool, but a tool that is based on this work that we have done so far. So there will be, we know that what we have done will be used not only by us, but by Swedish municipalities. And we will also like to use it ourselves for our air quality management work. So that's the start for us at least, and we hope that it will gain traction and be used even further.
Okay, so if I understood correctly, the system is accessible also from all the users, isn't it?
It's password protected and you need a login, but we can of course make it available for anyone who would request it and so on. There are some restrictions of the input data, how that can be used further, since it's not our data, all of it.
Okay, okay, thanks a lot. So let me check if there are some questions from participants. Okay, it seems everything has been pretty clear. So just to follow on the next, I have another candidate for this slot. We have received a request by Ivarsson. Can you hear us, Par?
I can hear you perfectly, yes.
Okay, wonderful. So we'll assign you the presenter role. You should have it right now. Okay. Okay, the floor is yours. Please kindly present yourself and your intervention, and then start. Thank you.
Thank you. There are two different branches of the AirCloud, and one is the development that SMHI has made. The other one is actually based on the Enviro system. It's a quite old system. It goes back to 1990, but it's always been troublesome to set it up for new simulation areas. Our aim for this has been that it should be easy for the changes we have made to the product, is that it should be easy to set up for a new client, for a new simulation area, and that it should be possible to be used for smaller consultant studies. A typical Enviro installation is for a city or a region or even a country, and it has been time consuming both to set it up for smaller consultant studies and to work with the system. We don't have a lot of time here, so I hope everybody can see the Enviro login screen. This is the same in the some 50+ installations that we have in the world, and I will try to log in here then. This is in a server in Sweden, and I'm currently sitting in South America. So when we log in, we will actually see a list of the available domains that we have in a system. These are physically separated, so there can be many clients using the same machine, or in the case of a national system, for example, you can have one domain for each region. I will select the little domain that's called the ref here. When I press the domain, then I can actually see the different modules we have here. There are mainly three. It's EDB that has to do with emissions, it's dispersion to run dispersion simulations, and then there are these modules that begin with Indico that has to do with data collection of air quality data. We have some rather big networks using the Enviro system, so it's not only for modeling. The British National Network, for example, with some 180 stations are using Enviro. I will set up a new domain. So then we have a module here called domain setup. So I will click on that one. And now we can actually see to the left the main menu. And here I can give my domain a name. So I will call it Linköping, where we live. This actually works worldwide. And I can select for the data collection of data, which kind of data I want to store in my database, the time resolution. And I can decide what kind of operations I want to do with this time series data. If I want to write time series data to the database, which is normal. If I want to enable data collection, and if I want to enable post-processing of time series data. And I do apply. Then I can go to maps here. And I have a link to Sweden, so it's a little bit slow. Here I have the whole world, and so here I can actually zoom in to the area that I have of interest, and I will go for Sweden. This is OpenStreetMap that we are using. And here I have Linköping, then, that is a Swedish city close to Norrköping, where you will be, I suppose. So this will be my the area that I want to simulate for them. I need to select the projection. Enviro is always working with Cartesian coordinate systems. So I go for a Swedish one here, and I do next. Here I need to give it a two-letter unique identifier, the viewport, the thing I want to see, and I will call it Linköping. Here I actually have a resolution of 250 meters. I can change that, and I can change the area if I want to, but I won't do that. I do update, and it should be the same. And now I do apply. So now I set up a new simulation area. One of the problems we have is to get good enough meteorological data. This is not available normally via the web, but we have made an import interface that should be able to handle most formats. I won't do that just now because it will take some time, but I have created my domain. So if I log in again, then I should be able to select my domain I just created. That was called Linköping. And there I have my little domain. And now I can go to dispersion, for example. If I go to results here, there is a preloaded result actually. And when we created the map area, the viewport, we also calculated physiography and topography for the area, so I can actually view this. I have to go to viewer here. And this is actually the topography that we can see of the area. So here you have a lake that is, of course, has a lower topography than the rest of the city, and it's going upwards in this direction. I can also select to view the set 0, that is the friction. And it's looking like this, so we can see that over the city itself, where we have houses, etc., the friction is a lot higher than outside the city, where it's nearly only open fields. And down here we are beginning to have big forests, so the friction actually increases. So this is important. I will just switch to. I shouldn't do that. If I go back to the viewer again, I can actually select any emissions if I have any. If I go again and click on emissions here, and I want to create a new road, for example, if I then click on the map, because I don't have any roads here, then I can do add. Otherwise, if I had clicked an already existing road, I would be able to edit that one. So I do add here, and then I can draw the little road on the map. So there I have my road. I have to give it a name. It's a little bit slow, I think. There we are. I will call it test. I can have preloaded emission models here of two kinds actually. So I could, for example, preload HOBEFA emission factors. There is a specific interface for that in Enviro under the emission database. Or I can actually use another version that's called road types that can also go for direct emissions. Should be able to. The most important number here is the number of vehicles. The emission is proportional to that one, so I could put 25,000. And if I do apply here now, something went wrong, of course. If you give me a second, if I do it like this instead. Now I'm creating a new EDB. I think that was the problem. So there I have a new empty EDB now. Now if I go to viewer again. I have my emissions. And there I can select roads again. Oh, it's the famous demonstration bug, actually. Just give me 1 second here. I've been doing something strange. Now, if I go to viewer, I'll change the EDB now. That's good enough. Emissions again, and I want to add roads. I click and I can do add, and I will add the road here. We'll see if it's working better. It takes some time for it to load. Text. And I go for emissions again. Now I can actually select the substance for the emission factor I'm going to add. So here I can add the emission factor for all the vehicles, then, saying 10,000 micrograms per kilometer. I change the number of vehicles to 2,500, and I do apply. So now I'm actually added my road here. And I can do the same thing with point sources and with areas, actually. I won't run any simulations here and now, but I can show you how it looks like. So I will change the domain over to the domain called ref. And here I can actually go to EDB here and select EDB that has been pre-made called blob copy. It's an old emission database from Gothenburg. I need to load a result. I need to load a result. Now, if I go to viewer, I will actually see that result. This is an old result. It is in Gothenburg, and I have one point source here for the moment from the result. I can go to emissions and select roads. and then I should be able to see the road network here. And now I can actually click on the road. Sorry, now I can click on the road, and I can choose to edit that road. So it's quite fast to set up a new domain, and it's easy to add emission sources and to do a small simulation. I will do a simulation for a short period of time here. So I will select time period, and I will just do it for 1 hour, and I do apply. Seems that I have chosen the wrong model, so I have to now disregard those. It's quite slow. Now I should be able to run a Gaussian one instead, and so I still have, I actually changed EDB, of course. Now if I select load copy, so this is for 2 hours, and I do apply, and I can do watch. It will probably be very quick actually. And this is a little bit strange. Now let's see if we can have the result here. And there we have the result. So now I can look at it. And I can do apply and show here, and I will see the result. So here I have the results for the first hour, and I can go to the next hour. Of course, I can do a simulation for a whole year. Here I can actually show the roads and the emissions. Just as before, if I click on the road, sorry, I need to show some emissions. If I click on the road, then I will actually be able to change the data for this road. We have also developed a number of interfaces for importing emission data. To get emission data inside the system is one of the most trickiest tasks. Actually, to create an emission database for a whole city, it requires quite a lot of work. So I will open the other module, the EDB, where I can actually define emission models for roads, emission factors for point sources, etc. Here in EDB, we can actually manage shapes, so we can actually upload shape files with either road point sources or grids. When I have them uploaded, I have 3 new interfaces here: import grid from shape, import road from shape, and import point from shape. I can go to the import road from shape, and I have the new road domain, I suppose. Shapes. I should go to the ref one. And the EDB. So here I have 2 different shapes. And by selecting a shape here, I can actually use the data I have in the shape and mapping that over to the database. And that is the same with point and grid sources then. Point and grid sources can also be in text format and CSV formats. We have also made an interface for importing CAMS data, so it's now possible then to get the CAMS data, the background data over Europe for the whole system. I think that was all from my presentation. I'm sorry that there were some problems. It's still a development version. Any questions?
Many thanks, Par, for your kind presentation. Don't worry about it. Some problem that could rise when facing an online presentation. It is normal when a system is still under development phase. So thanks a lot for showing us your concrete improvements. And I don't have any question from the floor. I had a question, but you already replied, because it seems that the system is able to ingest also user-side dataset, I mean to upload user-side datasets. And I think, considering that there is no question from the floor, I thank all the presenters for the valuable information. I kindly ask to the webinar participant and also the future visitor to the webinar to access the service that is being shared today. And thanks to all. The webinar is closed. Have a nice day.